In lesson 1, we're going to take a look at scale drawings. So let's make some different scale drawings. So on page 6 in your student workbook, you'll see this activity. So we see that Diego took a picture of a hippo. So here's your original hippo drawing or picture. And then here are 2 images that he edited. Which of these images looks like it is distorted from the original? And how can you tell? And then is there anything about the pictures that you could measure to test whether or not there has been a distortion? So go ahead, talk about that, pause the video, and come back. So probably you talked about that figure A looks to be distorted. Okay, it does not look really like the original because it looks squished. Okay, so it looks wider and shorter than B does. So B looks the same, but just a little bit smaller. So some things that maybe you talked about being able to measure is maybe the heights. And you saw that each of these 2 images were half the original height. And then maybe you looked at measuring the width. And you saw that this figure A stayed the same width, where B also reduced the width by a half. Okay, so this one only reduced the height, not the width, where this one reduced both by a half. So we're going to be looking into this. This is called a dilation when we kind of change the scale factor. So this is on page 7 in your workbook. You'll see this definition at the top. So it talks about a dilation. A dilation has a center point. Okay, so we've got the center of dilation, much like we did the center of rotation. So we've got this point O at the center. It is staying in place. Then we're going to have some scale factor that is given to us. So a scale factor of 2, a scale factor of a half, a scale factor of 4, whatever it ends up being. And that is going to take and move this point P, whatever's being dilated, along the ray. Okay, so there's this ray that connects the center of rotation to the point that you're dilating. So if you just kind of extend that, this point is going to move along that ray. Okay, so here's all the possible dilations of point P. Okay, along this ray. And where point P prime lands is going to be the scale factor times further away from O as P is. So let's take a look at what that means. So you have this original distance. Okay, so you have how far it is from O to P, and I'm just going to call it D for distance. So this is how far our original point is from the center of dilation. Then we're going to figure out where our image goes by taking the original distance and multiplying it by the scale factor. Okay, so whatever this given scale factor was. So if this original distance was, let's say, 10, and then we had a scale factor of double or 2 times, then you would be doing 10 times 2. And that's how far P prime is from O. So if this is 10 and our scale factor is 2 times, then P prime is 20 units away. Or if your scale factor was a half, half of 10 is 5. Or if it was triple, it'd be at 30. Okay, so you take your original distance times your scale factor, whatever that ends up being. So go ahead and look at drawing numbers 1 and 2. Okay, so dilate point H and K, given the center and the scale factor. One thing I do want to mention here is it does say 40 millimeters, but it's not drawn to scale. So when you're using your ruler to measure this, it's not going to equal out to 40. So as you're trying to do the distance times 3, you're going to need to measure it on your ruler to figure out how far it actually is so that you can figure out where H prime would go. So pause the video, take care of that, and come back. So let's take a look at a couple of things now that you've done that. Okay, so first of all, how did you get started? So hopefully you took and measured the original distance like I talked about, okay, and actually figured this out on the ruler. So this one's actually looks like it's about 56, 57. I'm going to do 56 because it'll be easier for me to calculate for you. But so this is actually 56 millimeters. And then the scale factor here is 3. So I'm going to multiply this by 3, okay, which will give me 168 millimeters. That's where I'm going to need to place H prime. So that's actually 16.8 centimeters, which is too long for me to get here. So I'm just going to do this a couple of times. So I'm actually going to just measure this 56. I'm going to move this. Okay, and I'm going to measure 56 centimeters. Okay, and then I'm going to do it again. So now I'm going to measure 56 centimeters from this point. So I've done that scale factor 3 times. Okay, so then you could just connect this. So you're doing it along this ray, right? And so then here is where that H prime would go. Okay, it's 3 of these away from C. Okay, so H was this far from C, so H prime is going to be 3 of these. So then I kind of measured to the second one and then measured to the third one. Could also show you with this segment, whoops. So this is that length, so doing 1 more of them and then another one. So this is 3 away from that original. Okay, three of them away. So that's something you could have done in this second one. So again, measuring this segment. So again, 56 for me, different for you in your textbook. Okay, but so this is 56 millimeters for me. And then I'm going to do 56 times a scale of 3/4. Okay, and you could do 3 divided by 4 in your calculator to get 0.75. And actually multiply that out and you would get 42 millimeters. So on my ruler, I actually need to measure 42 millimeters from point O. So point O is the center of rotation or dilation, sorry. So 42 is going to be right here. So then this is going to be point K prime. So we left the center the same, okay, and measured there. So taking a look at these, why would these 2 examples be incorrect? Okay, and so for this one, so if this original is 40, whoops. So if this original is 40, 40 times 3 is the 120, but that's how far it should be away from C, right? Not from H. So they did, they multiplied by the scale factor correctly, but then they did it from the wrong point. So then they measured it from H. So they actually should have measured that from C. So this is where H prime should have been. So then this one, they did do 40 times 3/4, okay, or times 0.75 and got 30. But then they measured the 30 from K again, instead of from the center of rotation, which is O. So then that that K prime should have been here. It should be from the center. All right, so go ahead and look in 1.3 and you're trying to dilate this whole figure by a scale factor of 1/2. So from center P. So in this center P here, okay, so this point stays the same. So this is where you're measuring to every single point in the diagram. Okay, so you're measuring from P. So if I do to D, so P to D is 21. So if I'm trying to figure out where D prime is going to go, I'm going to take the original distance, 21, times the scale factor of 1/2. So 1/2 of 21 is 10.5 millimeters, or 10.5 centimeters. So I'm going to go and measure that. So 10.5 is right here. So then this is where D prime would go. Okay, then you want to measure where C prime goes. Okay, or, so you're going to be drawing a circle, you're going to need a compass. You could also measure this length and then do half of this. Well, you are going to need to know where C goes, so I guess we are going to have to get C. So that we can, because that's our center, to figure out where our compass is going to go. So go ahead and get this to measure to C. So put your ruler there and figure out how far it is to get to C. So mine looks to be 22 or 20.2. So then we'll do C prime would be the 20.2 times the scale factor of 1/2, so 10.1. So then you're going to stay on this line and go to 10.1. And now those numbers will change for you, right? Because yours is a different amount in your book. Okay, but use your ruler. So then there's C prime. And then you'd be able to grab your compass, set it on the center, open it to another point. So open it to D. And then draw your circle. Now you could keep going with all these other ones. Okay, so if you want to set it on to P, so keep setting it on. Make sure your 0 line is on P. Okay, and then you're turning the ruler to get to these other places, doing half of them to dilate those points to get that scale drawn. Once you've kind of moved all the points, then number 2 is what things do you notice and what things do you wonder? So you can pause the video and work on that for about 10 minutes. All right, so hopefully you got most of that dilated. If you didn't get the whole thing, hopefully you got a good chunk of it. But what did you notice and what did you wonder? So go ahead and talk with each other just about your notices and your wonders, and make sure you get some of those written in your book on page 7. So some things to think about after doing that. Did the actual point change size when it was dilated? Okay, so the point itself isn't changing size. What's changing size is the distance away from the center of dilation. Okay, so the point doesn't change size, okay, but the distance from the center of dilation does. And what does a segment look like when it's dilated? Okay, so when we dilate a segment, what does it look like? So it's either looking, I would say, you know, longer or shorter, right? Still looks like a segment, either a longer version or a shorter version. So if the scale factor is less than 1, a shorter version of the segment. Okay, if the scale factor is bigger than 1, a longer version of the segment. So go ahead and get these 2 definitions written into your reference chart. So you can pause the video and get this written down. So when you have 2 figures like this, if the radius in this one is 1 and the radius in this one is 1/2, the scale factor is either 2, okay, or 1/2. And why we say that is you can either be going from this one as the original to this one, which would be the 2, okay, or you could be saying this bigger one is the original and we're going to the smaller one, that would be a 1/2. Okay, so either way, if you're going smaller to bigger, that's a scale factor of 2. If you're going bigger to smaller, that's the scale factor of 1/2. Then this one, dilation, so get that written in your reference chart. Make sure you're marking up this picture that's in there. So the distance, what this is saying is the distance from the center to the image is equal to the scale factor times the original distance. So here's your original, right, to the letter without a prime. and then that center to the prime is your image distance, right? So your image is equal to scale factor times the original. And in order to name a dilation, you say the object using what point as the center, and you have a scale factor. So dilate A using center P and a scale factor of 2/3 or something like that. All right, then we've got the lesson summary, and I would encourage you to kind of underline and highlight some things in here as we're reading through it. So in this summary, we said a scale drawing of an object is a drawing in which all of the lengths in the drawing correspond to lengths in the object by the same scale. So if we've only kind of reduced the height by a half but not the width, then that doesn't work. So everything needs to be at the same scale. When we scale a figure, we need to be sure to scale all of the parts equally. So everything needs to be scaled the same. Otherwise, it'll end up distorted. Creating a scaled copy involves multiplying the lengths in the original figure by the scale factor. And that scale factor is the factor in which every length in the original figure is multiplied when you make the scale copy. So just like here we said all the parts. So take everything, multiply it by the scale factor. That will be your image lengths. If the scale factor is greater than 1, it enlarges the object. If it's less than 1, it shrinks the object. What would happen if it was equal to 1? So if the scale factor is equal to 1, the two shapes would be congruent. They wouldn't be bigger or smaller. They would be identical. So for example, on this picture, okay, so if we've got BC, so BC is scaled of DE. So this is the scale of DE. So DE is the original. And BC is 1/4. Scale factor at 1/4. So here's your original. BC is 1/4 of the original. So in this case, then they're just putting the segment lengths to it. So we're saying this one is DE. So the length of this is DE. So then BC, this segment, is equal to 1/4 of segment DE, however big it is. So they just give you an example. If DE was 6, then we do 6 times 1/4, which would be 1.5. So this one is getting smaller by a factor of 1/4. So you just take the original distance times the scale factor to get the new distance. And then if we had this one, it says perform a dilation. We need the center, so A, scale factor, 1/4, and something to dilate, DE. So then a dilation with center A and a positive scale factor takes point D along that ray. So you'll notice that D's image was B, so it stayed on this ray, the ray that connected A to D. So then B is on that ray. C is on the ray that connected A to E. And then they've got the scale factor of K. So one more little example with that would be if the scale factor was greater than 1. So this one was less than 1. So if it's greater than 1, then it's getting larger. So you've got DE, and then the scale factor of 3. That's going to make D 3 times further from A. So we'll take this distance and triple it. That's going to get us to F. And if we take this distance and triple it, that will get us to G. Consequently, that will also take whatever this length is here. So if DE is 15, we would triple that, and we would get FG, which is 45 in this case. So here's a cool down to see if you kind of have control over what we learned in this lesson. So go ahead and talk about this with your group, okay, or try it yourself, pause the video, and then come back. So this one is just trying to match different scale factors. So some things that we know when we look at it, if it's equal to 1, the segments are going to be congruent. They're not going to change size. If they're bigger than 1, so 3/2 is bigger than 1 and 2 is bigger than 1, these are going to get bigger. Okay, and less than 1, these are going to get smaller. So we take a look at this, we see number 3, these stay the same size. So this has got to be A, that's staying the same size. Then we see from FG to F prime G prime, this one gets bigger. Okay, so this one is either B or C. From FG to F prime G prime, this one gets smaller. So number 2 is either D or E. 4 gets smaller, so this is D or E again. And 5 gets bigger, so this is B or C. So then you can actually calculate it. Okay, so we say for C it's double. So we would take the original and double it. So that's not happening in number 1. So number 1 must be B. Okay, this one, 12 times 2 is 24, so that's C. Doubled it, so this one must be 3/2. Again, you can do it in your calculator. 12 times 1.5 will give you 18. So for these two, it's easier for me in my head to do 1/2. So I'll look for the one that's half the size. So 12 to 8, not half. 12 to 6, that's half. So this one is E. So that must mean that this one is D. And again, you can do these. So you can do 12 times 2 divided by 3 in your calculator. It'll give you 8. 12 times 1/2 will give you 6. 12 times 2 will give you 24 here. And also 12 times 1 will give you 12 here.